Hey, hi everyone. I hope you all are doing good. So, in my today's session, I'm going to explain about one more creational design pattern called prototype. Okay, so let's start with it. What is a prototype design pattern? Okay, the prototype pattern is a creational design pattern in software development. Okay, it is used when the type of objects to create is determined by a prototypical instance. Okay, so just think of it as a initial copy or a base copy or a initial configuration or a base configuration which will be same across all your instances, only a little here and there changes in the state. Okay, so that's what they are saying. It is used when the type of objects to create is determined by a prototypical instance, which is cloned to produce new objects. This pattern is used to avoid subclasses of an object creator in the client application, like the factory method pattern does. Okay, in factory method, what we did in abstract factory, we keep on creating the subclasses of the product as well as the abstract factory, right? For each and every product, we will create its respective factory. So that's why you will see basically a hierarchy of classes basically in terms of product as well as the abstract factories. Okay, so to avoid the inherent cost of creating new object in the standard way, that is using the new keyword. Okay, one of the most important use of prototype design pattern is to avoid the resource expensive and the very expensive operation which new operator involves when creating a object. Okay, when it is prohibitively expensive for a given application. Okay, so in case of some applications or in the context of some applications, making use of this new operator to create new objects is not at all allowed. Okay, you should have some mechanism where you have an initial copy and you keep on copying that initial state so that you do a little changes to get a new object. Okay, which is basically cloning. Okay guys, so that's what this prototype design pattern all deals with. Now, to implement the pattern, the client declares an abstract base class that specifies a pure virtual clone method. Okay, any class that needs a polymorphic constructor capability derives itself from the abstract base class and implements the clone operation. Okay, so that's I'm going to explain soon. Okay, so the client, instead of writing code that invokes the new operator on a hard-coded class name, calls the clone method on the prototype, calls a factory method with a parameter designating the particular concrete derived class desired, or invokes the clone method through some mechanism provided by another design pattern. Okay, so when it comes to getting an object instance, we are not going to make use of new operator and hard code the subclass name or the class name. Instead, we will simply pass. Okay, in case of a factory design pattern or any other design pattern, we just give a hint what kind of clone I want. Okay, so using that class, we simply call its clone method in order to get an initial copy or a clone of that object. Okay, so one such example is the mitotic division of a cell. Okay, see how you can resemble this prototype design pattern is the mitotic division of a cell, resulting into two identical cells which are same in configuration, which are same in attributes. Okay, so that's an example of a prototype that plays an active role in copying itself and thus demonstrates the prototype pattern. When a cell splits, two cells of identical genotype result. In other words, the cell clones itself. Okay, so let's go through the overview. So the prototype design pattern is one of the 23 gang of four design patterns that describes how to solve recurring design problems to design flexible and reusable object-oriented software. That is, objects that are easier to implement, change, test, and reuse. Okay. So the prototype design pattern solves the problems like how can objects be created so that which objects to create can be simplified at the runtime. This is basically a runtime polymorphism which we are going to use. Soon I will show you in the prototype design pattern. So based on the type of concrete class, basically your clone method will return you the copy of that. This is very nice, and C# provides a built-in mechanism to clone that, guys. Okay, so I think most of you would have know that, so I will soon explain. Okay, so that is the first point. And second point, how can dynamically loaded classes be instantiated? Okay, so creating objects directly within the class that requires the object is inflexible because it commits the class to particular objects at compile time and makes it impossible to specify which object to create at the runtime. Okay, so That's also one reason why we go for the prototype design pattern. Okay. Now, the prototype design pattern describes how to solve such problems. Okay. What it says, define a prototype object that returns a copy of itself. Okay. You define an initial state, okay, an initial profile or an initial prototype, okay, that needs to be copied whenever the instance of such object is required, and then create new objects by copying a prototype object. Okay. So this enables configuration of a class with different prototype objects which are copied to create new objects, and even more prototype object can be added and removed at the runtime. Okay. So we'll go through the the UML diagram for this. Okay. So structure, as you can see, the UML class and the sequence diagram. I have omitted the sequence diagram. So class diagram is sufficient for our purpose. So you can see here, this is the client application or the main class or the main program in our object-oriented programming. So we have a prototype and base class, an abstract base class or an interface, okay, which basically defines a pure virtual function or abstract method called clone. Now, whatever class which implements this prototype, it will provide the implementation for clone. So basically, if there are n number of class are inheriting from this base class, base abstract class, okay, then they will provide their implementation of clone to provide the copy basically. Okay. So that's what I'm going to explain here. See here, they have provided only clone, but yes, in real-time examples we can provide some initial class members, or you can say properties of a base class or a prototype object which is common across all object instances. So that is the most important thing. Okay. So calling the clone method copies to itself and returns a product one object which will be in turn accessed by the client application by the product interface. Okay. So that's all about the class diagram. Sorry, the UML diagram. Okay. So there are some rules of thumb. Okay. Sometimes creational patterns overlap. There are cases when either prototype or abstract factory would be appropriate. Okay. At other times, they complement each other. Okay. Abstract factory might store a set of prototypes from which to clone and return product objects. Okay, so abstract factory, instead of directly creating the product objects by using new operator and the hard coded subclass names, it can basically keep a set of prototypes, that's the initial or one single objects, okay, or initial copy of such objects, only one object reference or object you can say. And then whenever we request for such objects, right, the abstract factory can simply clone those prototypes and return the new objects. Okay, that's what they are saying. Abstract factory builder and prototype can use singleton in their implementations. Okay, abstract factory classes are often implemented with the factory methods. Okay, that's the creation through inheritance, but they can be implemented using prototype also. Okay, so this can be done using prototype. So often designs start out using factory method, which is less complicated, more customizable. Subclasses proliferate and evolve toward abstract factory, prototype, or builder, more flexible, more complex. Okay, as the designer discovers where more flexibility is needed. Okay. So prototype does not require subclassing, but it does require an initialize operation. Yes, as I already said, you will get an initial configuration. So you need to initialize the prototypical instance which you acquire by the clone operation and set the required state to that. Okay, so the factory method requires subclassing but does not require the initialization in case of the factory method pattern. Okay. So designs that make heavy use of composite and decorator patterns often can benefit from prototype as well. I'm soon going to explain this composite and decorator patterns, but this is basically composite pattern is basically a containment or a aggregation. Okay, one object reference holds another object basically. Okay, one object holds another object you can say, and decorator, as most of you know, it basically acts as a container to an object. Okay, so in such cases, I think prototype fits well basically. So the rule of thumb could be that you would need to clone an object when you want to create another object at runtime. That is a true copy of the object you are cloning. True copy means all the attributes of the newly created object should be same as the object you are cloning. If you could have instantiated the class by using new instead, you would get an object with all attribute as their initial values. Okay. For example, if you are designing a system for performing bank account transactions, then you would want to make a copy of the object that holds your account information, perform transactions on it, and then replace the original object with a modified one. In such cases, yes, you would go with the clone operation instead of again constructing that object using a new operator and setting one by one properties by yourself. Okay, so let me go through the sample now. I have created a simple program for this. Okay, so let me explain. Let me change it to composite. So I have changed it to prototype design pattern. So that's my namespace, and let me start with it. So my prototype, see, if you see my UML diagram, okay, I should have an abstract base class or interface which provides an abstract method called clone, which is called, this class is called a prototype, or you can say a base configuration. Okay, so a template basically, which your prototypes concrete classes will inherit from and clone them. Okay, so that is my prototype, that is the car profile base. Okay, just see the properties: model, price, owner ID, owner name. See guys, how I can use this prototype pattern over here. My model and price, okay, won't change. Okay, whoever be the owner, okay, any number of owners who buys this particular car, right, for them the model is same, the price is same. Only thing which is going to change is owner ID and the owner name. Based on the purchase, we will set the owner name and owner ID. Okay, so this is a trivial example which will give us a scenario of making use of prototype design pattern. Okay, so in my case, only model and price, these are the two properties which will remain same for any number of instances of this class. Okay, sorry, the concrete classes of this particular base class, but there will be n number of, you can say 50 or 60 properties which are not going to change, which will remain intact or which will remain same for any instances of this car profile. Okay, so imagine like that. Okay, so this will basically specify my prototype. Okay, so only things which are going to change, or a minimal state properties which are going to change, are owner ID and owner name in my case. So look at the implementation. So it has an abstract base class and it provides an abstract method called clone, which should return a car profile base, and a display method just for the sake of displaying the information I have provided. Okay, so then I will go to the concrete class, which is called car profile. Okay, and I'm making use of the C sharp's built-in method called member-wise clone provided on the object class. Okay, the system.object class, which provides me basically a shallow copy. Okay, uh, there is a concept of deep copy and shallow copy in C sharp. So member-wise clone basically returns a shallow copy, which means the objects, each and every property will be copied to new object bit by bit manner. Okay, but if your but if your object contains any object references, okay, or if your class basically contains any objects, okay, apart from primitive types, in that case what happens is, in case of shallow copy, it will just copy the reference but it won't create a new object and set to that. Okay, so this thing we have to always remember in case of member wise clone in C sharp. Okay, member wise clone always provides a shallow copy. So all your primitive properties like int, char, bool, all will be copied in a bit by bit manner. But if your class contains some object references, then only the object reference will be copied to that object reference variable, not the newly created object. So if you want to achieve that, then you have to explicitly create that object and again call this dot memberwise clone on that. That will give you that particular object. Okay, and then set that newly created object to your object member of your class. Okay, so that's a little intro for the member wise clone. Okay, so in my case I don't have any object reference, or this particular class is not holding any object members. That's why I'm simply calling the this dot member wise clone, which should give me all these four properties filled with the new filled with their values in a bit by bit manner. Okay, So that's it. I am providing a implementation for clone, okay, which is coming from my base class, okay, that is what public override car profile based clone. So this should give me a copy of my object on which I'm invoking this clone method. So if I come to main method now, very simple. I have to maintain an initial state. Okay, so what I will do, I will register my car profile as a singleton in my IOC container. Okay, just take it as an example here. Just imagine that scenario. So car profile, I will register it as a singleton object, so which I call it as the initial state. I will set the model and price. Remember this factor. Model and price are not going to change for any number of object references. They will remain intact. It will be XZ plus and the price will be 10,000 rupees only. Okay, it won't change for a customer, each and every customer for this model. Okay, so that's what I have set here. Now see what I'm doing. On the initialize state, I'm calling the clone method. Okay, once I clone, all this newly created or this newly cloned object, or you can call it as a car profile one over here, it is a cloned object, so it is an exact copy. Okay, it's an exact copy of my initial state. Now what I will do, my model is price, model and price values will anyway automatically come into my newly created object. Only thing is I have to set the owner ID, which is A1, and owner name is something, some user like Bhuvaneshwar Kumar. Again, I will display my car profile details, and again I clone once again on my initial state. I will get second car object, car profile object. Again I set the owner ID to A2 and I call it owner name as Manoj Kumar. So if I run this program, so if you see here, very simple. The car detail, the first car detail, it's XZ plus. Its price is 10,000 rupees. But see, the ID is A1 and user is Bhuneshwar Kumar. In the second case, it's XZ plus 10,000, but now the ID is A2 and the user is Manoja Kumar. Okay. So only minimal state, minimal attributes of a states are getting changed, but most of the states like model, price, and a n number of attributes, which are same for all the object instances, will be very easily created by using the prototypical or the prototype design pattern. Okay, so that's all about prototype design pattern. Okay, thank you for listening and have a nice day, guys.